Yes, let's start the class. So please confirm is my appointment. Do we start screen sharing? Yes, is the screen visible? Someone please confirm.
It is visible.
Okay. So we will start with one topic. See, I am telling you one thing. I am going in a different order from what with respect to what ma'am taught. Ma'am taught some other order. I am teaching some other order because this is my teaching style. Okay. So I am teaching dimensions first. Okay. First of all, we'll be seeing only for n tuples. Okay. Don't ask me what is dimension for polynomial, for matrix, and we'll see later. Now we are studying only for n tuple. Okay. Now what is dimension? Now dimension of n tuple, we have many definitions. I will give you the simplest definition what I have in my hand, that is number of free variables present in n tuple. This is known as dimension of the n tuple. Now the question is, what is free variable? Okay, listen carefully. Suppose I am taking field as real numbers. I am taking vector space as r squared. Then I can write vector space like this. I can write x comma y for all x comma y belongs to real numbers, correct? Now please try to visualize. X can have any value, can have any value. So I am saying that it is free. Similarly, this is also free, correct? Now can you tell me how many free variables are there? There are two free variables. So I can say dimension of given vector space will be 2. That's it. Understand? Is there any doubt? Number of free variables present in n tuple, we can call it as dimension. Okay. So if you take another example, suppose I'm taking field as real numbers, I'm taking vector space as r cube, then I'll have b as x y z for all x comma y comma z belongs to real numbers. Here all are free, correct? All are free. So I can say dimension of which is 3. Dimension of vector space will be 3. Okay. So in general, I think we have got the point now. Dimension of vector space R per n will always be n. Okay. I hope this part of dimension is clear. Very simple topic. Okay. Dimension. Now we will see some other concepts in dimension. Now suppose I am giving you field as real numbers. I'll write question 1. I'm giving field as real numbers. Vector space as R squared. Find dimensions of the following spaces. Okay, now we will find dimensions of subspaces. So I'll give W1, I'll give this is R squared, vector space is R squared, 2 tuples we are seeing, x comma y, 1 minute, R squared, x comma y for all x plus y equal to 0. Okay, someone please try to tell me what is the dimension of this subspace. Please someone try and tell me. One answer from somebody.
Is it 1, bro?
1, yes. How do you do it?
Because y is dependent on x, so we cannot say it is free.
Very good. That's it. Simple. Okay. So you are having. So you can suppose see this. Suppose I'm telling I can write this equation as y equal to -x. Now imagine I am keeping this free. If I'm keeping this free, then this is not free. This has to depend on whatever value x getting. I can write x comma y. I'm applying condition x plus y 0, and I can rewrite n2 plus x comma minus x. Now if you observe carefully, how many free variables are there? Only one. So I can say dimension of W1 will be 1. Simple, right? Try to visualize what this means. Now I'll tell you one thing. It is not compulsory that you should write only like this. You can also think like this. Suppose you can write x as minus y. You can keep y as free, and you can say this is bound. Okay. You can also write it as minus y comma y. Even here you will get same dimension. Okay. So don't think y here on I kept x free. You can keep anything free, but at the end you will get only dimension as 1. Okay. Any doubt on this? If you have doubt, please ask. Okay. I hope this is clear. Now second example I'll give. Suppose I'm telling W2 I'll give us x comma y for all x plus y equal to 0, and I'm giving you 2x plus 2y equal to 0. What is the dimension of this vector of this subspace? Someone please tell me.
One.
1. Very good. Why? See, because these two conditions are both are same conditions, correct? See, it's looking like you're having two conditions, but there's only one condition, correct? So this also you can write as x comma minus x. So I can say free variable, I can say you're having 1. So I can say dimension of W2 is 1. Actually, both are same. This question and this question both are same. Okay, if you understand. Hope you are getting it. Now we will see third question.
So what is different
What?
statements?
What?
What if we have different conditions? Like 3x plus 2y is equal to 0.
You're asking. You see the next question. That's what I'm going to give next question. Now, after this question, if your doubts is there, then you please ask. Okay. So W3 I'm writing x comma y for all x plus 2y is 0, and I'm saying 2x plus y is 0. Now tell me what is the dimension of this? I think this is what you're asking, right?
Yes, bro.
That's what I know. This is the third sum. Now do this question. What is the dimension of this?
2.
Vector space, subspace. Sorry.
2.
2. No. Answer is not 2. Answer is not 2.
Same one.
No, answer is not 1.
0.
Is it 0, bro?
Wait.
Yes, dimension is 0. When you are
Dimension
solving,
is 0.
yes, dimension is 0 only. Now you are solving simultaneous equations. Okay. When you are solving both simultaneous equation, you will get x comma y, you will get as 0 comma 0. Now look at this carefully. X has no choice. X is free. X is not free. X 0. This is compulsory. Y is 0. This is also compulsory. Who's free here? Is anyone free here? No one is free. So no free variable. Okay. So you can say dimension is 0. Are you understanding this? Are you understanding this?
Yes, bro.
Nice.
Yes,
Okay.
bro.
Now look at this carefully. You need to do visualization also. Okay. This is nothing but line. If dimension is 1, this is nothing but line. And if dimension is 0, this is nothing but point. So in any linear equation system, if you are getting dimension as 0, then you will have unique solution. That is, you will get point. Okay. So you need to visualize the dimensions also. Now let me just give you some list of things. It's very obvious. Let me just give a list. If dimension is 0, it is point, correct? If dimension is 1, then it's line. If dimension is 2, it is plane. If dimension is 3, it is 3D space. Now listen, we can have any set of dimension. We can have dimension 4 means we can say 4D region. Dimension 5 we can say 5D region. But the problem is we know only how to visualize till 3D. Okay. It's not that this is not there, it is there. Some people say 4th dimension is time, 5th also, any set of dimension you can take, but we can't visualize, that's it. Our visualizing tendency stops here. Okay. Anyway, it's all there. Okay. So I hope this is clear. Okay. If there's any doubt, you can stop me and ask. All this is a very simple concept only. Now I will give you next question. Question 2, I'm giving field as R and I'm giving vector space as R cube this time. And I'm asking find dimensions of the following subspaces. Okay. This is R cube. Okay. So first I'm giving W1 will be XYZ for all 0x plus 0y plus 0z is 0. What is the dimension of this vector space of this subspace?
3.
Very good. Why? Because this essentially means that all are free. meaning dimension is 3. Actually, if you observe carefully, this is the whole vector space. W1 is the whole vector space. Not even a subspace. It's a whole vector space written. Okay. So any doubt, keep asking. Second question. W2 will be x, y, z for all x plus y plus 3z is 0. Very simple question. You don't have to solve, keep solving. I can write. I can just take. Suppose I'm taking this as I'm taking this free. I'm taking this free. But x will not be free. I can write minus y minus 3z comma y comma z. So in real, I'm having only two free variables. Number of free variable is 2. So I can say dimension is 2. So if dimension is 2, I can say it's a plane. Okay. And you studied 3D. You studied this is plane, right? This is plane only. So you studied, and what we are studying is coming. Okay. Now third question. W3 will be x comma y comma z for all x plus 2y equal to 0, x plus 3y plus 2z is 0. What is the dimension then?
One.
Answer is 1, correct. Now, tell me, Gautam. Gautam need to tell the answer, I think. Yeah. Now, how did you get the answer as 1?
So I took x as free, so y is dependent on x. So if I substitute that y dependent equation on the second equation, I get x as a dependency on x. See, y, z as a dependency on x.
Okay, very good, very good. Correct answer. Okay, you can do like that. But if you observe carefully, you are going to have many. The work you are doing is increasing. You understand this? See, in these questions, it was very simple to find free variables. Okay, it was very simple. Okay, but in this question, you're having two equations, you're having a 3 tuple. Your work is increasing. Okay, so I'm going to teach another method, another shortcut. So there's a shortcut, not shortcut. It's also understandable, but we'll see a formula to find dimension faster. That formula you need to understand. So what that formula, listen carefully. See, listen carefully. You are having initially you are having some free variables. Initial number of free variables you are having. Okay. What you are doing? You are subjecting it to some conditions. And now you are getting, finally you are getting some variables. Okay. Understand? Which means freedom is reduced after these equations are applied, correct? Example, suppose I'm having x, y, z initially. I'm applying one condition. Here freedom was 3, but here freedom will reduce to 2, correct? Reduced freedom. So are you understanding this? 3 minus 1 will be 2. This is the formula we need to know. Dimension will be number of variables minus number of independent equations. This is a formula, but you don't have to think like a formula. You can try to understand this formula. Initially, this much was free. Now we are reducing the freedom by giving some conditions. When you minus initial freedom minus reduced freedom, when minus the condition, you get reduced freedom. Okay. Now if you apply this to this question, x plus 2 equal for we are having x, y, z, and we are adopting two equations, correct? X plus 2y equal to 0, x plus 3y, x plus 3y plus 2z is 0. You can say dimension will be, initially there are 3 variables, there are 2 independent equations, so I can say dimension will become 1, so I can say 9. Is this formula clear? This is a new formula I've introduced. Any doubt in this formula? It's very logical. I'm not telling you to memorize at all. Think logically, that's it. Initially, how much freedom was there? Now we are reducing the freedom by giving some conditions. Now this is the final resultant freedom after imposing all the conditions. Any doubt on this? Can I proceed? Someone tell me. Till now what I have taught, is it clear? Any doubt on this? Hello? Yeah? Any doubt on
No,
this?
bro.
Can I proceed? No?
Yes.
Okay.
No, bro. Yes.
Very good. So this is a third question I did. Now I'll give you some 2 questions. You tell me what is the dimension. Okay. So I'm giving W4 will be, I'm giving x comma y comma z for all x plus y plus z is 0, 2x plus 3y plus 4z is 0, and 4x plus 5y plus 6z equal to 0. Please tell me what is the dimension of this vector space of this subspace.
Zero.
The answer is actually wrong.
No.
The answer is wrong. Sorry. Read the formula again. Formula is number of variable minus there's one word which you need to be very careful about. What is this? Independent equations. So please see that one more time. It's not a problem. I can't waste a lot of time. So I'll teach you how to do it. Okay. See what is dimension? Dimension is 1, correct. Yeah, your answer is correct. Is number of variables minus number of linearly independent equation, correct? Now the question is, we have 3 equations. Do we know they are linearly independent? We don't know. Okay. So we need to devise a method to find out whether all the equations are linearly independent. Listen carefully. Number of linear independent equations. How to calculate? Listen carefully. Is equal to rank of matrix of coefficients of variables of equations. Just writing for formality this much big statement just for you to remember. Now I will show you what to do exactly. Okay. So what you're doing is you take a matrix, write all the coefficients like this. Look at this. Write all the coefficients. 1, 1, 1, 2, 3, 4, 4, 5, 6. And now your work is to reduce it to row echelon form. I hope you know what row echelon form is. Ma'am has done the class multiple times. So what I'm doing is I'm keeping this as reference, and now I'm doing R2 implies R2 minus 2 R1. I'm doing R3 implies R3 minus 3 R3 minus 4 R1. So if I'm performing the operation, I'll get 1, 1, 1. I'll get 0. Do it. 1. I'll get 2. I think. Come on, you should keep checking. Okay. So I don't want to make mistake. Into 4, 1. 4, 2. Yeah, I hope I'm right. Now I am keeping this as reference. Okay, see, I'll keep this as reference. I want to make this 0. Now I'm keeping this as reference. I want to make everything below it 0. I want to make this 0. So how will I make that 0? I'll be doing row 3 implies row 3 minus row 2. So if I'm doing that, I will get 1, 1, 1, 0, 1, 2, 0, 0, 0. That's it. How to check row echelon form? You take all the pivots. Take the pivots. Take the pivots. That's it. There are only 2 pivots here. This is not a pivot. Pivot can only be like this. See, you're not understanding the word pivot. Not a problem. I will put a YouTube video where they're discussing in detail about rank pivot. Okay, I can't sit and teach all that. Lot of time will take. So I cannot teach all that. So these are the pivots. Below the pivots, everything is 0. Okay, there is no, that's it. So all these are 0. So then I can say this is in row echelon format. This is row echelon format. And what is rank of matrix? Rank of matrix is number of non-zero rows in this matrix. Now tell me, this is 0 row, meaning there are only 2 non-zero rows, correct? There are only 2 non-zero rows. Look at this carefully. In the row echelon format, in row echelon form, there are 2 non-zero rows. So what can I say? Number of independent equations. What will be? So what is independent equation? Equations will be rank. What is rank of matrix? Will be 2. Okay, what is it? Now you apply the formula. Dimension will be number of variables minus independent equations. 3 minus 2 will get dimension as well. This is clear? Is there any confusion in this? Now you understood how to find dimension when they are having many equations? See, what is the meaning of this? It means all equations are not independent. One of the condition is waste. See, I'll tell you, see, this condition actually, if you try to see, if you are satisfying these 2 conditions, this will automatically get satisfied. It is not extra condition at all. That is the meaning. There are only 2 independent conditions. Okay, there are not 3 independent conditions. Only 2 independent conditions are there. Third condition is extra waste condition. Anyway, If you satisfy this two, this will automatically get satisfied. That is why it's a waste. Okay. Any doubt in this? Can I proceed to next question? Fourth question is clear. Can I proceed to fifth question?
Yes, bro.
Very good. Yeah, 6 questions are there. Yeah, fifth. Come on, please do it fast. We will try to do it faster. So fifth question will be W5 will be x comma y comma z for all x plus y plus 2z. This is for actually practice of row echelon form. You should try to practice it better. 3z is 0, and I'm giving 5x plus 4y plus 10z 0. So I'm not giving time to solve. I can do it. Why should we waste time? You understand the method. Now we will do it. Take 1, 1, 2, 2, 1, 3, 5, 4, 10. Okay. Now you're taking this as pivot, and you are doing row echelon form reduction. You will be getting R2 implies R2 minus 2 R1. R3 implies R3 minus 5 R1. You will get 1, 1, 2 minus 1 minus 1 minus 2 minus 1. Please check I'm doing correctly. So minus 5 minus 1 is 0. Correct? Yeah. Now I'm keeping this as pivot, and I'm performing row 3 implies row 3 minus row 2. In performing the operation, you get 1, 1, 2, 0 minus 1 minus 1, 0, 0, 1. Okay. Now, if you're observing carefully, this is row echelon format, no problem. Okay. And if you're observing carefully, there is no 0 row. All rows have at least one non-zero element. So I can say rank of matrix is 3. This is definitely, this is like this is denotation for rank, like symbol of rank, row symbol. Rank of matrix is 3. Okay. So I can say rank of matrix is 3. So I can say number of linearly independent equations is 3. So I can say dimension will be number of equations, number of variables minus number of independent equation. So I can say dimension will be 3 minus 3. I can get dimension as 0. Dimension of W5 is 0. Any confusion? Meaning this is what is the meaning of this? Solution is a point solution, or I can say unique solution. Say unique solution. Okay. Can I go to next question?
Oh, is it mandatory to use echelon forms, or can we use determinant method to find the rank?
You can find determinant method, but if you find determinant method, suppose the rank is 1, then you need to, like, do you know how to find the rank using determinant method fully? Because suppose you are getting determinant of 3 by 3 0, you can just confirm that determinant is less than, the rank is less than 3. You cannot confirm whether rank is 2 or 1, correct?
Yeah, bro.
For that you need to again check each 2 by 2 determinant. If you know what I'm speaking, if you have studied rank using determinant, then you will understand.
This method is easy.
Yeah, sure. Yeah, because this method directly you can see how many number of non-zeros. So imagine this also came 0. Easily you can say this is rank is 1, right? But in a row with determinant form, you need to check each 2 by 2 determinant. Again, why instead of do row echelon forms? Yeah, actually, that many methods are there to find rank. Row echelon method is the best. Okay. So 6th question is the last question for this topic, and then I'll go to basis. Okay. So this question, please do it. I'm getting W6. I'm getting x, y, z for all x by 2 equal to y by 3 equal to z by 5. Please do this. Yeah, can someone tell me the answer? What is the dimension of this vector space, of the subspace? Sorry, telling vector space again, subspace.
One, bro.
1.
How do you tell it?
If x is a fixed value, then y and z depend on x.
Very good. That's what you can do is best. What you can do is w equal to y by 3 equal to z by 5. Keep it as lambda. Okay. So now you're saying 2 lambda, 3 lambda, 5 lambda. If you observe clearly, all of them are slaves, and lambda is the free variable. So only 1, right? So I can say dimension is 1. Yeah. One more way of doing this problem, I'll tell you. What you can do is you can take these two equations together. You can say these two equations together. You can say 3x minus 2y 0. You can say I'm taking this and this together. So I'll say 5x minus 2x 0. That's 0. You'll have only two independent equations. If you take this and this, it will be repetition. Okay. Take this and this, take this and this. Okay. Don't take this again. It will become repetition. I'm telling you also. So now we can say number of linear equation equal to 2. I can say dimension will be 3 minus 2. I can say dimension is 1. Dimension of W is 1. So, but this is the best method. See, wherever whichever method is best you do. Okay, for this question, this is best. Okay. So, are you all clear with dimension? I hope it's clear. Okay. Can I go to next topic?
Yes, bro.
Now we will see what basis and span. Please look at this very carefully. What is basis and span? We'll try to understand it. See, now what I'm doing, we need to do visualization again telling you. Now I'm taking field as real numbers. I'm taking vector space as R cube, meaning I'm taking 3D plane. Okay. What I'm doing, I'm going to draw some things. Please try to understand. This is a 3D table. Okay, this is a table. This is a table. Okay, try to visualize table. This is x-axis. This is y-axis. Take this is z-axis. Okay, is it clear? You understand this table arrangement? Are you able to visualize? 3 planes, the 3 axes, x, y, z is coming out of the table. X and y are on the table. Okay, this is the 3D plane. Look at this very carefully. I am having a person A who is standing at coordinate 1, 2, 3. Okay. I'm having another person B who is standing at B. I can say -1, 4, 7. Okay. But please listen carefully. What I'm doing is both of this they are inside their homes. Okay. His home is here. His home is here. Now both of them have met online for the first time, and they have become very good friends, and they want to meet. Now they are deciding that they will meet in house of B. Okay, they are deciding that they will go on. That A will go to B's house and he will meet B there. So A is making phone call to B, and he's asking, "Hi B, I want to come to your house. Can you please tell your house address?" Because he has not gone before. B is saying, "Oh, I'll tell you. My house is at -1, 4, 7." He's saying like that. Now if you observe carefully, A is a very weak in mathematics. He doesn't understand. What? What are you saying? -1, 4, 7. Please give more clarity. I am not understanding what you are talking. He's saying like that. So B is thinking, how can I tell him directions? B is thinking, how to tell this man? Like, he doesn't even know coordinate system. How to tell him directions? So B is coming to a very good solution. What B is doing is just keep it here. So what B decides is, B is telling him, see, I'll teach you what is coordinate system. This is called x-axis. And if I'm telling you, if I'm using the word I cap, just move along x-axis by 1 unit. Clear? So I'm writing I cap like this. And J cap, if I'm telling means go along the y-axis, J cap like this. K cap I'm telling means go along K cap like this. He is first teaching A about coordinate axis, and then he's telling A. B tells A this. Move 2 units opposite of I cap. Then he is saying move 2 units in direction of J cap, and he's saying move 3 units in K cap. See, so he's saying this on phone. A is saying, oh, wait, I'll come. Now I understood. He's coming like this. So he came this he came. Then he is going like this along Y. Then he is going along Z, and finally both friends met. Is this story clear to everyone? Anyone has any problem with the story? This is a story of how B is telling how to come, how he's instructing A how to come to his house. Is this clear? Any doubt on the story? I mean, with the story only, I'm going to explain what basis and span is. That's right. So, are you understanding what the story is?
Yeah, bro.
Respond. The story understanding. Oh, very good. Look this carefully. Now, listen carefully. These three vectors I, J, K. What they are doing? They are helping in navigation, right? They are helping in navigation. Now, and they are controlling whole 3D space, right? They are controlling whole 3D space. These 2 points try to note. They are helping in navigation. They are controlling whole 3D space. Now we will see what is definition. Now these are known as bases of R cube, and this is known as span. Span means it's a region of control, something like that. And basis means vectors controlling that region. So this is what you are calling by base and basis, and this is span. Are these two terms clear? What is basis and what is span? Any doubt in these two terms? If anyone has any confusion, please ask. What is basis? What is span? Tell me. Can I proceed next concept?
A span is like controlling whole 3D space.
Yeah. Can I proceed? See it one time. Yeah. So we'll just proceed. So look at this very carefully. So I'm taking another. This is I'll take it as a first example. Second example. Now this time I'm taking. See, listen carefully. K is the standard basis. Standard and most commonly used basis. But it is not that we should always use this basis only. Okay. The whole chapter we are going to see different types of basis, whatever other types of basis we can use. Look at this carefully. Now suppose I'm giving basis as I, 2I and J. Now the question is, can they span R cube? Can someone answer this question? Can these three vectors, what I have given, can they span R cube? Is it possible? Yeah. Someone please respond. Can they span R cube? Is it possible?
What is span?
Everyone here, no? See, span is the region of control. Meaning, can these vectors cover? Can they handle fully? Can they handle something like that?
No, they can't handle.
Suppose someone, it can't handle, correct? Why?
Because they don't have the control of z-axis.
Very good, correct? They don't have control of z-axis. Suppose someone is talking about going to 5k cap, you cannot control, so they do not span R cube. So how do you tell? Listen carefully. Can I say this is waste vector? Why I'm saying this waste vector? Look at this carefully. See, what work this itself can do, right? Eh? What work this itself can do, then why should we have this is waste, right? This basis, this set of vectors cannot handle k components, so they cannot span R cube. Clear? So they cannot span R cube. Any doubt? Is anyone? Now only we are starting the questions. So are you understanding? Anyone has doubt? Please ask. See, they cannot handle any third. Can I handle k? I can't. Right? Can't handle. Okay. So third question is I'm giving I and J. Can they span R cube? Answer is same reason what you gave here. So I mean, not wasting time for this. This also doesn't handle because they cannot handle k component. Fourth question, I, j, I plus j. Can they handle R cube?
No, bro.
Why? Same reason, right? Same
Same
reason.
reason.
If you observe carefully, this is very straight now. What work these two can do together, that's why this is doing. Then why you should take separately? And these are useless, but this is waste, correct? So they cannot span. Heptan can span. They cannot. You're asking, can they span? Okay. Okay. They cannot span. Okay. Now fifth example, I'm taking 3i, 2j, 5k, 2i plus 3j plus k. Just tell me whether I can span. Think. Can they span?
Yeah, they can, but we still have a waste vector here. Third, fourth one,
Very
I think.
very good. This is the answer expected. Yeah, very good. They can span, but 4 of them cannot form bases. When you are saying bases, all the vectors should be useful. All these three are useful, correct? They can span, but you cannot say they form bases because this is waste. So the answer is, suppose the question they're asking, can they span? Yes, they can span. They can span R cube. You should write R cube. But they cannot form bases. If you take these three, they can form bases. Clear? Why? Waste, and there are too much, correct? So there are only 2 vectors. This is too less. Here there are 4 vectors. This is too much. These 5 examples you should then try to reanalyze. If you sit and reanalyze these 5 examples, then you will come to 2 conclusions. What are those conclusions that I'm going to write now? Listen carefully. All vectors must be linearly independent. That is, I should not have any waste vector. Secondly, number of vectors must be equal to dimension of Are these 2 conditions clear? If you analyze all the 5 examples, you will come to this conclusion. All vectors must be linearly independent, and number of vectors should not be not less or more. See, we have seen one example for less. This is too less. We saw an example for too much. Okay, and we saw example. See, this here we are having 3 vectors, but this is waste. This is linearly dependent on this 2, so this is waste. So, but if you see I, j, k, there are 3 vectors, and all of them are independent, so they can form a basis. Any doubt in this? These condition you should remember. Now what I can do is I can combine 2 conditions. I can combine both, and I can say in one line, number of linearly independent vectors should be equal to dimension of span. Number of linearly independent vectors should be equal to dimension of span. Okay. Get out of this. You can also say, you can define dimension like this also. Get out of this. Tell me, any doubt in this? Can we proceed?
Yeah, proceed.
Huh? Okay. I will give question. Which question number this is? This is question number Question 1 on this, question 1. Question 2 I gave R cube. Okay, I'll give question 3 here. So I'm giving question 3. I'm giving field as real numbers, vector space as R squared, and I'm asking following sets of vectors of the so I'm giving two tuples first, R squared. Okay, so tell me, suppose I'm having 1, 2 and 3, 4. Can they form bases?
Yes.
Very good. Why? Because we are having number of
dependent and
vectors 2 at dimension of R cube is R squared is 2, so they can form. Correct. Very good. Next question. I'm giving 1, giving we have same thing again. 2, 3, 7 and 21, 49. Then can they form bases?
no.
Reason?
Linearly dependent.
Yeah. What are number of linear independent vectors?
1.
What is dimension?
Dimension should be 1.
No, dimension should not be 1. How can you change dimension?
Dimension is okay.
Question dimension is fixed. You can't change dimension. Okay.
Okay.
Question dimension is fixed. Okay. And out of this, can I proceed? I'll directly give. I'll directly go to fourth dimension. The third dimension is very familiar. We'll do something which is not familiar. So I'm giving question 4. Because I'm giving vectors. I'm giving field as real numbers. Vector space I'm giving R power 4, and I'm telling check if the following set of vectors can form basis of R power 4. So I'm giving you 4 vectors 1, 2, 3, 4, 1, 2, 3, 2, 2, 5, 6, 4. I'm giving you 2, 6, 8, 5. You need to check whether these vectors form a basis of R power 4 or not. Now if you observe carefully this question, we could just see with our eyes that they are independent. This also is independent because this is dependent. Into 7 we can see. So we can say that the vectors are linearly dependent. But here you cannot do that. There are 4 vectors. You cannot check. You cannot with your eyes. You cannot say whether they are linearly independent or dependent. So to find whether linearly independent or not, what you will do is take vectors as rows of matrix. Then rank of matrix is equal to number of linearly independent vectors. Just like how we did independent equations, same concept we can say rank of the matrix will give you number of independent vectors. So what you will do? You will do reduction to row echelon format. That's it. Please do row reduction. You keep doing separately. Even I'll keep reducing it, and we will check. Please check whether your answer is correct. That's all. You just need to practice reduction to row echelon form very well. Okay. So if you're observing carefully, I'll do row 2 implies row 2 minus row 1. I'm keeping this as pivot. Please note it. And I'm doing row 3 implies row 3 minus 2 R1. I'm doing row 4 implies row 4 minus 2 R1. So I will get 1, 2, 3, 4, 0, 0, 0, minus 2. I will get 2 minus 2 into minus 2 into minus 2 1, 2 minus 2 0, 2 minus 2 minus 4 minus 2 0 into minus 2 2 into minus 2 2 into minus 2 minus 3. Am I right or not? Huh? Someone check now because I am. First things we want to have confidence. Someone very patiently will be. I'm correct, right? I will Please someone verify whether this is correct. Whether I have done proper row operation, someone please verify.
It is correct.
It is correct. Okay, now look at this carefully. Second pivot is not that correct. See, second we are having 0. We cannot use this as pivot, correct? So what we will do is we will perform row exchanges. Listen carefully. What I'll do is I will do row 2 interchange row 3. If you interchange vectors, that's not a problem. Okay, 1 2 3 4 0 1 0 minus 4 0 0 0 minus 2 0 2 2 minus 3. Now I can take this as pivot. See, I can take this as pivot. Now whatever below is 0. This is already 0. I'll make this 0. How to make it 0? Perform row operation. So what operation you will perform? You will perform R4 implies R4 minus 2 R2, correct? So I'll write 1 2 3 4 0 1 0 minus 4 0 0 0 minus 2. Oh no, correct. And 0 0 2 5, correct? Right? Yeah, hope I'm right. Now again we don't have pivot here. Okay, so again we'll do row. See, this is 4 by 4 is maximum they'll ask. Okay, that's what ma'am also said. So we'll practice. Only one question I'm doing. I'm not going to do 5 6 questions with this. Just one question we'll do like this. 1 2 3 4 0 1 0 minus 4 0 0 2 5 0 0 0 minus 2. Okay, now it's in row echelon form. See, these are the pivots. See, these are the pivots. Everything below pivot is 0. So I can say this is in row echelon format. Correct? Please check it. I am checking. Yeah, so I verified it online also. So I can say this is row echelon format. So I can say there are no 0 rows. See, all rows have non-zero elements. So I can say rank is 4. So I can say this is equal to dimension of R power 4. So can I say this form basis? Can I say these 4 vectors form basis?
Yes.
See, this is the method you have to obtain. You understand? Any doubt on this basis? Okay.
Sure.
Yeah. Now there's a last topic. So time is 4:55. By 5:15, I think I'll wind up. Last topic is that subspace span. With that, we'll finish today's class. Okay. So we'll see.
Prajwal, can you hear me?
What?
Can you hear me, Prajwal? In
Yeah,
the
I can hear
previous question,
Yeah.
how you find the dimension?
How you find dimension?
Yes. Previous one.
Dimension of R power 4 is what?
No,
See,
no, no.
Initially I wrote dimension of R power n is n. Dimension of R power 4 is what? You're having A, B, C, D. What is dimension of R power 4? 4 variables are free. And I'm getting rank of matrix. Rank of matrix is number of independent vectors. See, number
Hello.
of independent vectors.
Before this question.
Before this question, which question?
Yeah, the second one.
How I found dimension? Dimension of R squared is 2. This is dimension of R squared whole vector space. I'm not talking about this dimension. Dimension of R squared is number of linearly independent vectors. Meaning, yeah, you can say the dimension of this dimension of 2 will be 1 only. That is not matching with dimension of the total vector space. So they cannot form a basis. Yeah. Is that clear?
Okay.
Yeah. Notice clear? Can I proceed?
Yeah.
Okay. So last topic, 20 minutes will take. We'll see what is subspace span. So see, suppose I'm giving you field as real numbers, vector spaces R cube. Okay, and I'm giving you vectors I and j. Okay, I'm giving only two vectors. I'm giving. Now question is that we have already seen that they cannot span R cube. Why? Because linear independent vectors is 2, not equal to dimension that is 3. Correct? We cannot have two vectors. This is 2 less. Correct? But it can handle any vector in 2D plane, that is this is clear. Is there a doubt on what I have written? I cap and j cap you are having. It cannot cover the full 3D plane, correct? It cannot cover full 3D plane, we have seen obviously. Okay. It cannot cover full 3D plane. But it can definitely cover small part of 3D plane. If you observe carefully, suppose I'm taking vectors as 1, 0, 0, that is I cap. I'm taking j as 0, 1, 0. What is dimension of this now? What is dimension of this? This I can take a subspace, right? What is dimension of subspace? Dimension will be 2, correct? Because there are two independent vectors and I can say that it's a plane, correct? So I can say that this region covered by only I and j, that is subspace span. So I can say xy plane is subspace span of ij in R cube. Are you understanding what subspace span is? See, till now we found all these bases, and all these vectors, they span the full R power 4. They span full R power 4. If you see this example, it spans full R squared. But if you take this example, it does not span full R squared, but it has dimension 1. Meaning, it spans a particular portion of R squared, not full R squared. What we did is all these questions, this cannot span full R cube. It can span just one particular plane in R cube. This also it cannot span particular. It can handle some particular plane in R cube. This is called, that particular region which it covers is called subspace span. Okay. Any doubt in the subspace span? Can we do questions in subspace span? So what I can say, subspace span is subsplit of full span. That's it. Yeah. Questions. Always carefully. This will be question number 5. Okay. Question 5. In the condition that vector A, B, C belongs to the span of 1, 2, 0 and 1, 2. Listen carefully. I'm giving field as real numbers. Vector space I'm giving R cube, correct? Because there are 3 tuples. See, there are three commas. There are 3 variables for big 3 tuples. You observe carefully. You're having number of linear independent vectors is 2. Okay, but dimension of R cube is 3. Meaning vectors do not span R cube, but I can say, okay, what is number of linear? Can I say dimension of subspace will be 2, meaning plane. Meaning I can say vectors span, that is they control particular plane in R cube only. My question is, suppose I am bringing third vector. I want to ensure that now what is condition that ABC lies on plane. This is the question. Okay. This is the question. Now I will tell you how to write the answer. Take a matrix with 1, 2, 0, minus 1, 1, 2, A, B, C. Like this you take. Okay. Listen very, very carefully. So you need to ensure. Now we already know that this ABC vector. This is not independent. This is not independent, linear independent. It depends on given vectors. Is this clear? ABC, this is not free. This depends on this two. Linear combination we can write. Because this lies on the plane. See, imagine if this is free, this is also independent, then rank of matrix will become 3. If rank is 3, you're having 3 variables, but we want only dimension 2. So I want to ensure dimension equal to 2. See, this is a little conceptual topic. If anyone is not understanding this, please tell me now itself. We need to ensure that this if we are ensuring this dimension is 2, then I can say that this is only plane. Suppose dimension becomes 3, then it's not plane, right? It will become full 3D space. I want to ensure that this also lies on this plane. I want to ensure that. Understand? So tell me, can I proceed? Can I continue solving, or you want me to give some more conceptual clarity? Your wish. Tell me. Yeah. Gautam, is it clear for you?
It is clear.
Prem, everyone is clear? Right.
Yeah.
Others, if it's not clear, you can please stop me. So what I'll do is I'm trying to now try to bring into row echelon format. Try to bring into row echelon format. So what I'll do, 1, 2, 0. I'm having 1, 2, 0. I'm having minus 1, 1, 2. I'm having A, B, C. Okay. So now I'm trying to bring to row echelon format. I am keeping this as pivot. And what I'm doing, I'm performing row operations. Doing row operation, what I'll get row 2. No, I'll just do one new thing. Listen carefully. I'm going to introduce something new. I'll keep this as vector U. I'll keep vector V. I'll keep this as vector W. Okay. Just see what I'm doing. Try to understand what I'm doing. Okay. Listen carefully. Now I'm performing row 2 implies row 2 plus row 1. Row 3 implies row 3 minus A row 1. If you're doing this, yeah, if you multiply A and it will get subtracted. Multiply by A and C. So now you will get 1, 2, 0, 0, 3, 2, B minus 2A. This will be C, correct? Minus 2A it will be C. Now look at this carefully. Now the calculation is going to, and listen carefully. What you are taking, this is vector U. You are taking this is vector V. You are taking this is vector W. Whatever operation you are performing on this side, you also perform this side. Meaning this cell write as U, this cell write as V plus U, this write as W minus AU. Tell me, is this clear? And out of this, I am writing this two matrices side by side. Whatever row operation I am performing on this, I am performing this also. Okay. So look at this carefully. I am taking this as now listen carefully. I am performing. First, see, I want to make these two elements equal. Only then I can subtract. So what I'll do is just look at the row operation I'm performing. I'll just do row 3 implies 3 row 3. I'll just multiply it by 3. So if I'm multiplying, what will happen? 1, 2, 0, 0, 3, 2, 0, 3b minus 6a, 3c. Now I'm performing another row operation to make this 0. This 0. How will I make it 0? I will do row. Yeah, I should write this also. Right? I forgot. U v plus u 3w minus 3a u. So now I'm performing row operation. Performing row 3 implies row 3 plus what? 2a minus b into row 2. Performance, are you getting 0 here? You just check. So what I'll do is I will do like this. I will keep third row constant like this, 3b minus 6a, 3c. I'll multiply this row by 2a minus b. 2a, this will be 6a minus 3b. And if I'm multiplying 2 into this, you will get 4a. You get 4a minus 2b, correct? So if you're adding this, writing this is rough work. Now I'm writing the actual work here. So here you will write 1, 2, 0, 0, 3, 2. Just add this, you will get 0, 0. You will get 4a minus 2b plus 3c equal to, you will get uv plus u. And what you are doing here, you are writing 3w minus 3au. You are plus 2ab times this plus 2a minus b times v plus 2a minus b times u. For this also, whatever row operation you are performing, just perform it. Okay. So this is rough work. I'll just keep it side by side. Right here. So now I'm getting p plus u. So if I'm adding this, what will I get? I'll get 3w. What will I get? Plus u, I will get u. I'll get what? U, I will get minus a minus b times u plus I will get 2a minus b times v. Correct? Yeah. So I'll get like this, correct? Yeah, I'll get like this. Okay. So look this carefully. Now is it in row echelon format? Is this in row echelon format? Yes or no? This is row echelon format. Now we want rank is 2, meaning I want last row should be 0. We want this condition, right? We want to make last row 0. Only if we make last row 0, I can say that dimension of this will be 2, and I can say that this is still a plane only. So what I'm doing is now making last row 0, we will get 4a minus 2b plus 3c is equal to 0. I can say, I can call this as equation of subspace. We got equation of subspace. I can say condition. This is the condition for A, B, C to belong to the span of this two. Any doubt in this? This whole question, this is a very good question. It's a very standard question. Can you understand this? Please tell me. And one more thing, what we can do is this also should be 0, correct? Because this is 0 vector. So what I can say is, I can say 3w plus minus a minus b times u plus 2a minus b times v. This should be 0. Meaning I can write 3w as a plus b times u plus b minus 2a times v. Meaning I can write w vector, I can write as linear combination of these two. So this is also why. See, if I'm telling that this is the plane, this is the equation of the plane, I can say these two, this is u vector, v vector. These two vectors are handling the full plane. So suppose I'm telling w vector, that's what u and v, not w. I can say that if you're writing w is linear combination, this w also will be somewhere in the plane. Only if you're able to write w as linear combination of u and v, w will also be in the same plane as u and v. Any doubt on this? So the same question you can ask like this. Listen carefully. Same question. Different way of asking is find condition that A, B, C can be written as linear combination of given vectors. Exact same question, but asking different way. If they ask like this, you will do the same thing. You will do like this, and what you will do, you will just ensure that the dimension does not change. Any doubt on this question? This is the penultimate question. After this, we'll do one question and then we'll wind up the correctly 5:15 and leave. Any doubt on this? And I can say that linear combination is written like this. This is a linear combination. Example, suppose I am writing, suppose I want to express, see from this condition, I'll take some point. I'll take ABCS. I can take as what I can take. Tell some point now. 1, 1, what I'm doing? 4 to 2. 1, I'll take 1, 2, 0. Is that not satisfied, right? That is satisfied. So what I can do is I can write this as A plus B 3 by 3 times U plus B minus 2A. B minus 2A times, so 1, 2, 0 is already there. Okay, no, I want it 1, 2, 0. Take something else. Take 1, 4, 1 minus 4. Come on, tell no. Come on, give good example. I want a good example from this. Give a point from this plane. Tell me. Come on, tell me fast. Yeah. Hello. Come on, tell no. Tell some point from this plane.
032.
032. Satisfying, no? So check. Okay, sure. So I can write this as A plus B by 3. Yeah, give me 1 minute. So I can write this as A plus B by 3. A plus B by 3 times U vector will be 1. B minus 2A. Do B minus 2A. B minus 2A is what? B minus 2A. 3 by 3. I can write U plus B vector. So I can write this as, so any vector can be written as linear combination. See, if you add this and see, you will get 0, 3, 2. It is linear combo. So this is what the concept is about. Is it clear? Last question I will give and we'll wind up the session. This is question number, what is the question number 5? The 6. This is question 6. Condition that A, B, C this question I'll do. The next class we'll continue with the next set of questions. So this last question we'll do. So what I'll do, 1, 1, 2, 2, 3, 3, 1, 3, 5, A, B, C. Okay. To do it, and also write in the side by side. To write U1, U2, U3. This you keep as vector V. Okay. Now what you want to do? I'm not writing operation what I'm performing. I'll just reduce it. This will be equal to U1, U2 minus 2U1, U3 minus U1, V minus A times U1. Okay. And what you will do? 1, 1, 2, 0, 1 minus 1, 0, 5. So this will be A minus B. This will write roughly. This row operation roughly. I'll keep this row constant. Right here. I'll keep this row constant. Here. Where I'll write here. This row I'll keep constant. This row I'll multiply by A minus B. And I'll add both. This row I'll add and write the result here. So if I'm adding what I'll get 0, 0. If I'm adding I'll get minus 3A plus B plus C. This will be equal to whatever U1, U2 minus 2U1, U3 minus. This question is very long. What I'll do is I will write the question, I'll post it. It's taking a lot of time. I'll write the question and post it. Next class we'll continue this question, okay? U3, you can subtract and see, you will get it. So it's just taking time. Anyway, I told I'll leave at 5:15, time is 5:15. With this question we will continue next class, okay?
Prajwal, I just have one doubt in question number 5.
Definitely. Question number 5. Please ask.
You said to make that dimension as 2, right?
Yes.
Actually, the beginning dimension is 3.
Where is dimension 3? Dimension of the vector space is 3 pa.
So we are making the dimension of the subspace to be 2.
Dimension of given subspace is 2 only, you know. What is the dimension of these two vectors? Tell me. 2 only, you know.
2.
I am saying that ABC should belong to the same dimension. Meaning this should not alter the dimension. This should also be a part of the same plane. Understand?
Oh.
So see, suppose this is suppose I am writing this matrix. Okay, I am reducing to row echelon form. Here, where is it? Row echelon form. Here, where is it? Here. This is row echelon form, right? Here I am not getting 0. Meaning then this will become dimension 3. This will become the subspace. We want to restrict ABC as a part of the subspace. This is subspace.
Okay.
This is subspace. That's it. Clear? Huh?
Okay.
Anyone else has any doubt?
No.
No, clear.
All clear for everybody?
Yeah, bro.
Yeah.
So, ending the session.
Okay.
Thank you for joining. Bye bye.